Hey, what's up, guys? So today I want to introduce this. I don't know how to spell. I don't know how to pronounce it, but it's K-fancy equality, and also I think this equality is interesting. So I also have another video list. Basically, contains a lot of inequality. I think that they are very useful in the real analysis and the linear algebra. Okay, and I will post this link below if you're interested. And yeah, so let's go to start prove this inequality and give a statement. And I hope you guys subscribe to my channel. Yeah, so my channel usually do mathematics and some higher mathematics or lead code or physics or whatever you want. Okay. Yeah. Oh, okay. Something is weird. Okay, but it's fine that we don't care about it. Okay, so let's quickly explain it. So let's go to this K-function equality. Okay, so let me give the statement. So statement is that let's say you have a number. Let's say you have I from 1 to 2 to n, and then you want to then what? Then if you do the summation of I from 1 to n, and take a 1 over n roots, and let's say 1 minus xi. So obviously that this is just a symmetric process, right? So I from 1 to n, and this guy will less or equal to this. Okay, and okay, so yeah, this is the one inequality. Okay, so if you're okay, so I think everyone remember it. So one quick way to write is that you can define an to be the arithmetic mean. So basically, it's 1 over this. And then I think everybody knows about so-called geometric mean. So every guy and then take 1 over n's roots. And then you can define n prime to be 1 over n, I from 1 to n. Let's say 1 minus xi. And also you can define gn prime to be the same, be 1 or minus xi, I from 1 to n. And this. And this equality can be explained into written as, let's say, an divided by an prime. That's equal to gn divided by gn prime. Okay, so this is and I think you can check that when is the inequality holds. I think this is very simple. Right? You can check for yourself. Okay. Okay, so let me give you the generalized version. And after we prove the generalized, after this, then we can prove this generalized version, and then we can reduce our results to the first one. So this generalized version is basically, suppose somebody give you a gamma I, which is a weight, right? So each gamma I is from 0, 1, and the summation of I from 1 to n is 1. Then I get the summation of product of xi gamma I from 1 to n, and I from 1 to n, 1 minus xi gamma I. So there's a weight that's equal to summation of gamma I xi, and gamma I 1 minus xi. So I from 1 to n, I from 1 to n. Okay, so notice that, notice what? So if you choose gamma I to be 1 over n, then you reduce to the originally reduce to the originally k-fan inequality. Okay, because this is 1 over n and this is 1 over n, right? So this becomes arithmetic mean. Okay, so let's give it a proof. Okay, so the only lemma that I want to use is that I think this is from, if you don't know, you should go to check my video, the Jensen's inequality. Okay, so amazingly is that most of the inequality, at least in the real analysis probabilities, should be derived from Jensen's inequality. Okay, so this is really weird. Okay, so suppose f is a double prime less than 0 for some open interval. This is called concave, right? And in the concave world, if you have some positive number which is sum to 1, and you should able to check that, you should able to use your linear simple calculus to prove that the weights of the summation of this function will be less or equal to the summation of this. Okay, so this is concave, and if you change it into the convex, then you can go this. Okay. Okay, so how do we prove this? So proof. So this is very hard to guess, but let me just write down results. So if you define f of x to be log x minus log 1 minus x, the first derivative is 1 over x, 1 minus 1 over x. I think it's minus 1, right? So 1 over x plus 1 minus x. Now do the second derivative. Right, so this should be plus 1, right? Because there's a minus 1 when you do a derivative, and then there's not minus 1 here. Okay, so remember that your s, let's say your imaginary x is less or equal to half, right? So this guy is greater than 0. Oh, sorry, less than 0, right? Because right, if x is close to 0, then this guy will be blow up, right, with negative infinity. Okay, so that means f belongs to 0 and half concave. I should say open interval. Okay, to be 100% rigorous. Okay. Okay, so now everything is trivial, right? Because it's concave. So I can just use this inequality. Okay, so I get my summation gamma I f of xi, I from 1 to n is less or equal to summation f summation gamma I xi. Okay, so let me just write it down. So what is this? So this is long, right? So I mean you can combine these two to be the log x 1 minus x. Okay, so this tell you that you get I from 1 to n gamma I right log x 1 minus x I, right? So this term can be written as a log, right? So summation become a product, which is xi gamma I 1 minus xi, right? Gamma I, right? In turn, okay. This guy is less or equal to this, right? So it's gamma I xi, I from 1 to n, and take a, right? This is log, right? So take log 1 minus I from 1 to n, gamma I xi, and then remember that my condition is gamma I summation is 1, right? So this guy, this I can be written as a, let me just do it step by step. So do you, sometimes I feel life is difficult. I mean, especially when I do something stupid and keep filming some stupid video, YouTube video. Okay, so this, so your support is very important to my channel. Okay, so you get this at least, right? So this is I from 1 to n, I from 1 to n. Okay, then take the exponential, right? Take the exponential. Take the exponential, right? So this guy become a product I from 1 to n, xi gamma I from 1 to n, 1 minus xi gamma I, that's equal to the mean. I from 1 to n. Nice. Okay. And you can check for whether inequality holds. This is very good exercise for you. Okay, so basically you can check. I guess what inequality holds is that you can check for if all the xi is the same. You can check whether, yeah. Okay, so very just for some hint. Okay, so that's it. So yeah, this inequality is also maybe show some into some like the competition or IMO test. But this inequality is also, I think it's interesting. Okay, so hope you guys subscribe to my channel. See you guys next videos.